Parabolas. Parabolas are graphs of the polynomial of degree 2. Okay. So here I have the red parabola. It's a convex parabola. And the black parabola is a concave parabola. I have this dashed line here, which is the axis of symmetry. The parabolas are symmetric with respect to this axis of symmetry. Whatever happens on the right, it's a mirror image of what's on the left. These two parabolas have the same turning point, the same vertex. So this point here is the minimum point for the red parabola, the maximum point for the black parabola. It's called the vertex or turning point of the parabola. Okay? And I have these three important formulas, three ways to represent, three equations to represent the parabola. The factorized one on top, one in terms of the turning point, the vertex, and the usual polynomial way to write the parabola. Okay? Solutions, the x-intercepts of the parabola, x2 and x1, have the usual formulas. Assuming this delta is non-negative, this becomes two real numbers. If delta is 0, both numbers are the same. If delta is positive, we have two different real numbers. And if delta is negative, the parabola does not intercept the x-axis. Right? Like the red parabola does not intercept the x-axis. So for the red parabola, the delta is negative. For the black parabola, I have two intersects. So I have the delta strictly positive. Okay? All right, now let's take the derivative of the parabola. Let's pick up this first formula here and take the derivative with respect to x. So y prime equals, and I take the derivative. So that's a product. So the first, I repeat the first derivative of the second. Derivative of this is 1 minus 0. It's just 1. So I multiply this by 1. I find this. Plus this times derivative of that. Derivative of that is just a. Okay? So I put everything together. I know the a is different from 0, otherwise this is not a parabola, it's actually a straight line, right? To be a parabola, the coefficient a has to be a non-zero real number. And the parabola, the derivative of the parabola is 0, if and only if this term here is 0. That is 2x minus the sum of x1 and x2 is 0. That is, x is the average of x1 and x2. In other words, x is the vertex of the parabola. Right? To have 0 tangency, I'm at the vertex of the parabola. Okay? The parabola is increasing when the derivative is positive. So the derivative is positive. For this here to be positive, I have to have this a positive and this other term, the other factor positive, or I also have to be two factors negative, a negative and this negative as well. So first possibility, when a is positive, it's a positive number times another positive number. This has to be positive. That is, the x has to be bigger than the average of x1 and x2. But the average of x1 and x2 is just the vertex, the x-coordinate of the vertex of the parabola. Graphically, the situation is like this. A is positive, so it's a convex parabola, and it's increasing in this part here, which corresponds to values of x above, greater than the vertex, the x of the vertex. Okay? So the parabola increases if x is above x of the vertex, in this case for a positive. But there's another way this product of two numbers can be positive if both factors are negative. If a is negative and this big factor inside the square bracket is negative, then the product is positive. So I'm in this case here. A negative, and the x is below the x-coordinate of the vertex of the parabola. Okay? And the picture is this. Here I have the vertex, x-coordinate of the vertex. A negative means it's a concave parabola. Okay? So the function is increasing here in this branch of the parabola. When x goes up, y goes up only here in this branch, not on the other branch. That is, the x is below the x of the vertex. The function is increasing from minus infinity all the way to the x of the vertex. So the x has to be smaller than the vertex of the parabola. Okay? Now, we did that using this formula here. What if we take the derivative of the second formula? We take the derivative of the second formula, we're going to find this. So the 2 jumps in front, the derivative, using the chain rule, the derivative of what's inside is just 1. So the derivative of a constant is 0. Adding a constant 0 doesn't matter. So again, I have 2 possibilities to have this derivative y prime to be positive. Both factors are positive in green, or both factors are negative in red. In both cases, the product of 2 positives or the product of 2 negative numbers is going to be positive. So the derivative is positive, meaning the function is increasing in these 2 cases. If this factor here, 2a is positive, and then this is positive, a is above the x of the vertex, or second case, the 2 are negative. The 2 factors are negative, a is negative, and x minus x of the vertex is negative, so the x is smaller than the x of the vertex. Okay? So these 2 possibilities for the function to be increasing. And the 2 situations are in the 2 graphs that we just studied. Okay? Third formula, the usual polynomial formula for the parabola. We are here taking the derivative. We have that. The derivative is positive if and only if this is positive. Solving for x, we've had this. But here there's a tricky thing. The a can be positive or negative. If the a is positive and I divide both sides by 2a, I do not change the sign. Dividing by a positive number, I keep the sign of the inequality like that. So x is going to be bigger than minus b over 2a. X is going to be bigger than minus b over 2a, but this is when a is positive, right? And minus b over 2a is the x of the vertex, the x-coordinate of the vertex of the parabola. But it could be the case that this a is negative. If the a is negative, when I divide by 2a is negative also, I have to change the inequality, right? So if a is negative, this, instead of having this inequality, I have that, okay? Because I'm dividing by a negative number. So I obtain the same result in these 3 different ways using any one of the formulas. I can identify the part of the parabola where the parabola is going up. So hope you enjoy. Bye-bye.